I want to briefly talk about P1 and how grading works in general on my website. So let's start with P1. So from these programming problems, I mainly want you to do two things. So the first important thing is how to pre-process the data set. And second is how to implement a mathematical algorithm. So the first part here is actually very simple. So for P1, you just need to read a CSV file, and you need to convert it into a feature matrix and a vector of labels. So there's nothing complicated. But in the future programming problems, you do need to read an image and convert it into pixel intensities, and read a text file, for example, a movie script, and then convert it into some kind of text-related features. And you also need to deal with missing data and other problems with the data set. So here it's just simple. And second part is the harder part here is how to actually implement the logistic regression and neural network. So in my slides, I usually have these algorithms slides, the slides with subtitle algorithms in most of the lectures. And here it's basically an outline of how you should implement these stuff. So you need the inputs that you already got from pre-processing the X matrix and the Y vector, and then you will want to get these weights. So you just implement it step by step. So for example, the first thing you do is initialize the weights to random numbers between minus 1 and 1. So in case you don't know in your language how to generate a random number between minus 1 and 1, you should just Google how to generate random numbers between minus 1 and 1. Or since I'm posting the solution like 1 or 2 weeks before the deadline, you can actually look at the TA solution and find the line that does this, and then you can maybe copy and paste the line to your code or something. So that's the first part. And the second part, the activation, is just implementing the formula here. So you need a for loop for the dot product. So here you need a for loop, and you need a for loop to go through the instances as well, because you need to sum it up. And the weight update is they are just formulas as well, so you can implement them very easily. So one thing you may need to look up is what the C is. So it turns out is in one of my earlier slides called cross entropy loss. So you can look at the formula in the slides to how to calculate the C. And actually in the formula there is a log. So you need to deal with the problem with log 0. Because if one term is like log 0, is minus infinity, then the whole thing becomes minus infinity. So you cannot compare them. So you do need to deal with some small numerical problems when implementing these, but they should be intuitive how to figure them out. So when you code it, you will see the problem, and then you can figure out some simple way to fix those. And also, there are other problems of how to find the learning rate. So you can try the decreasing square root learning rate. I actually highly recommend you to do that for P1. But to figure out the initial learning rate, you can just try different things and see which one works, right? Because you can output the cost function, and you can actually see whether it converges or it becomes 0 at the end. So that's actually my recommendation of how you should start these programming problems. And let's get back to the grading part. So if you go down, there's a grade button. If you click it, hopefully it's 0. Yes, you get 0. I didn't enter anything yet. So if I load the TA solution, P1, it takes a while to load it. So we should wait. Yes, here something appears, so it's good. And then you click the load button. It will take a while, and you need to wait until this button goes back up. It's usually between 10 and 20 seconds, so it shouldn't be too long. If it's too long, you put something illegal in the text file. Okay, it's back up. Let's check. It's So everything's loaded. Let's actually plot the first one. Well, it looks like a 4. And let's plot the weights. Doesn't look like anything. It's okay. And let's plot the wrong one. I think the TA is classifying 4 and 7. This one, well, it's really not clear whether it's a 4 or 7, so it's okay. So it actually did a good job. And let me click grade again. So now grading will take a long time because it actually needs to activate the neural network and test if the output is correct. Let's wait. Again, 10 to 20 seconds. Okay, now it's done. Hopefully it's perfect. Yes, 46 out of 46. That's great. So let me talk about a few things about how this is actually graded. So first, I'm not grading the weights. So if there is a weight, then I give you 1 point. And I am actually grading the activation because I'm just loading your weights. I'm using your weights to activate my training set. And then I see if it's the same as your activation values. If they are the same, you get 10 points. And here, the prediction value, you are actually graded according to how well it is predicting stuff. So first, I want to check if your predicted values are consistent with your activation values. So for example, if your activation value is 0.1, you should predict 0. If it's 0.9, you should predict 1. So you should see something like this. So I can tell you here that the correct output should be all 0 for the first 200 and all 1 for the next, first 100 or 0, next 100 or 1. So here I think there are like 2 of them or 3 of them are incorrect. So I guess the accuracy is around the 98, 99%. And actually, if you check here, it is grading your accuracy. If it's above 50%, you get 2 points out of 10. And if it's above 75%, you get another 2 points, and so on. If it's above 95%, you get 10 points, 10 out of 10. So the neural network part is graded the same way. And one other thing I want to talk about is maybe you don't want to generate one file for each question here. You just want to generate a huge file like this one here that contains all the fields, and you can actually do that. So the way to write a file like this is first you need the same lines like output and ID, and then you can just have a line that says add and the field name, and then after that you just enter whatever you want to put into that field. And the question is, what are the field names? So for example here, the first one is called training. So this field here is the training field. So you can just write @training and then write a few lines or whatever you want that you want to put into this text field. And then if you generate a text file like this, then you can load it from here, an entire file that loads all the fields at the same time. So that if that's something that you want to do. And I actually want to talk about my code for grading these, but I think it's better to talk about homework, math homework 1. So if you look at math homework 1, and if you right click anywhere, if you select inspect, then this console will show up on the right. And if you click on console, it will show you the bugs. So if there's any bug, so for example, if you click grade and nothing happens like for a while, then there may be a bug. If you look into the console, you can see what the bug is, and you can post on Piazza the bugs. And the thing I actually want to show you is here in the sources tab. And if you look at the sources, And the two important files are cs540.js and y.js. And the one that's more relevant to you is cs540.js. If you click on here, you can see my code. And so, for example, for the first one, the function q sum geometrics generates this and grade this. So there are usually two important parts. The first few lines are used to generate the questions. So, for example, based on your ID, it sets a random seed, and then it creates a random number a, and here is 9, and a random number r, here is 0.7, and so on. And basically, if we're generating the question, it fills the blanks. And these are not what you are interested in. You are interested in the else part. If we're not generating, we're grading. And what I'm doing here is I'm just grading a scalar, and I have a formula for the scalar. So here, what you can basically do is you can put a, which is 9 here, and r 0.7, and so on. You can calculate this. And what I'm doing is actually comparing whatever you enter here with this number here. If it's right, you get the points. And so for these type of questions, from reading my code, you can actually see how the answers are generated. And for example, here, I may be grading a vector, and it shows what the vector is. And here, grading a matrix also shows what the matrix is. But there are some other questions that are more complicated. For example, the spanning tree one. So here, the spanning tree problem, the problem with this is there are multiple spanning trees. So you can have different answers, and all of them are correct. And so here, if you look at in the else block where I'm grading, I just get the object that you selected and check whether it covers the graph. So if it covers the graph, you'll get the point. If it doesn't, you will lose the point. And so similarly, if you look at the margin sum question, so what I will do is just I will get which cells you highlighted and actually sum up the row, sum up the column, and see if it's consistent with these column sums and row sums. So they are not graded by comparing it to a specific answer that I created, but basically I'm evaluating whether your particular version of the answer is correct. And this is done for all the programming problems. So for all the programming problems, I'm never generating the answers myself. I'm just loading your answer and check if they are correct or not. So you cannot use these code to actually get an answer for your programming problems. But for some of them, you can do it for the math homework. So that's what I want to talk about here. And lastly, I want to show you something about math homework 3, and because one of the questions is really easy. So Q2, for example, here, the answer is just 1 minus whatever the original accuracy is. So if you click calculate, you will calculate a number. But if you want to keep the expression, it's okay too. So if you keep the expression like this and not click calculate, and if you go down and click grade, it will actually grade this question correctly, and the answer will show up as the expression, not evaluated. So in case you want to keep the you want to keep the expression so that when you look at it, you know where it came from. So you can do that as well, because when I grade, I always evaluate the field instead of just assuming it's a number. And also, I also want to talk about something very small. So here, some of the weights may be difficult to see. So I made it so that you can move the nodes around so you can actually see which weight corresponds to which edge. So that's just a very small thing. And by the way I graded this particular question is actually the same as the way I graded P1, is I just put your weight into my network, and I just activated the network on these 4 instances. If given your weight, the activation is consistent with the output, then you get the points. Okay, I think that's all I want to talk about, and I'll stop here.